Okay. So today's class will be about the resonance in AC circuit. In last class, we have completed calculations for series and parallel RLC circuit, also for general circuits in polar and rectangular form. So we will start with the resonance today. In AC circuit. What do you mean by resonance? Actually, in AC circuit or in any circuit, resonance is between inductor and capacitor. The actual definition of for resonance in circuit is given like in any AC circuit, if the rate of change of electrostatic energy becomes equal to rate of change of magnetic energy. The circuit is said to be in is said to be in resonance. हमने अपना इंडक्टर और कैपेसिटर का एक्टिव रिएक्टिव पावर देखा था. In first half cycle, the power across inductor is negative. In first half cycle, power across capacitor is positive, reactive power. Now, when a capacitor is discharged, inductor is getting charged in the circuit. And also when inductor is getting discharged, capacitor is getting charged in the circuit. Therefore, this electrostatic energy is converted into magnetic energy and magnetic energy is converted into electrostatic energy. When the rate of conversion of both energies are same, it is said to be in resonance. Circuit is said to be in resonance. Circuit resonance में है. Circuit is said to be in resonance. But ये होगा कैसे? What is rate of change of energy? आप define कर सकते हैं? What is rate of change of energy?
Power.
Power. It means when a reactive power across capacitor is equal to reactive power across inductor, the circuit will be said to be in resonance. That means QL must be equal to QC. ये रेजोनेंस बहुत सारे सर्किट्स में होता है, बट हम लोग को दो स्पेशल केसेस देखने हैं. वन इज सीरीज आरएलसी सर्किट एंड सेकंड वन इज पैरेलल आरएलसी सर्किट. यहाँ से आपका कंसेप्ट ऑफ फिल्टर भी स्टार्ट होता है. नाउ पहला केस हम लोग देखेंगे, द रेजोनेंस इन सीरीज आरएलसी circuit. Now, we have a series circuit. We have R reactance XL, capacitive reactance XC circuit, and connected to an alternating voltage supply, say V. Clear? Now, since it is a series circuit, current will be constant or same in all the three elements. And by definition of resonance, by definition for resonance, this QL must be equal to QC. Reactive power across inductor must be equal to reactive power across capacitor. And since current is same, QL can be written as I square XL and QC can be written as I square XC. Now, this I square cancel. For resonance, XL must be equal to XC. ये दोनों जब equal हो जाएगा, the circuit will be in resonance. Now, what is XL? XL is omega L and XC is 1 upon omega C. Cross multiply. So omega will be equal to 1 upon under root LC. At this frequency, angular frequency, resonance will be there. Also, omega is what? 2 pi f. Now, it is a special case of resonance. Say we will be writing omega as omega naught. Omega naught means resonance frequency. Omega naught will be 2 pi f naught. It will be 1 upon under root LC. And f naught, the resonance frequency will be 1 upon 2 pi under root LC. Now, this is condition for resonance in AC circuit, AC series circuit. अलग अलग सर्किट में condition will be different. These are the conditions for resonance in series RLC circuit. Now also, a circuit में resonance कब होगा? We have discovered. Now, the circuit has special properties when it is resonance. What are the properties of this circuit when it is in resonance? This will be your next subheading. Properties of series resonant circuit. You can see that what is Z? Z is equal to under root R square plus XL minus XC whole square in polar form. Now, when XL is equal to XC, XL minus XC will be 0. Therefore, Z will be equal to nothing but R. In case when frequency changes or XL is more than XC, this will be positive. Positive plus positive is positive. Again, Z will increase. Or either XC increases. XC बढ़ जाता है, तो भी this will be negative. Negative plus positive. Again, positive plus positive will be positive. Z again increases. We can see first point. Impedance of circuit is minimum when it is in resonance. First property is at resonance, impedance is minimum. That means what is impedance? Z is equal to R. That is, circuit is purely resistive. अगर सर्किट प्योरली रेजिस्टिव है, then V and I are in same phase and power factor, that is cos phi, will be 1. Power factor of the circuit will be 1 in case of resonance also. अब इसको ऑब्जर्व करें. Since impedance is minimum, current will be maximum. Current is maximum in case of resonance. Other than resonance condition, current will be less than this current. रेजोनेंस कंडीशन में जो करंट मिलता है वो हमेशा मैक्सिमम होता है. ठीक. ऑल्सो अगर आप फ्रीक्वेंसी बढ़ाते हैं, ओमेगा इंक्रीजेस, एक्सएल विल इंक्रीज, एक्सी विल डिक्रीज. XL increases, that means the circuit will behave as inductive circuit, and if omega decreases, XC will increase and XL will decrease. Circuit will behave as capacitive circuit. At resonance condition क्या होता है वो आपने देख लिया. Now, if frequency increases, circuit behaves as inductive. Lagging circuit behave करेगा. Also, if frequency decreases, circuit behaves as capacitive. Clear? यहाँ तक कोई प्रॉब्लम? Again, sixth property. If variation of current is drawn with frequency, variation of current is drawn with frequency, आपको current कैसा मिलेगा? Say current is on y-axis, I, and this is omega. At omega is equal to 0, what is XC?
Infinite.
1 upon omega C. XL is omega L. XC will be infinite, that means reactance infinite. ये in open circuit behave करेगा, open circuit, and current will be 0. Similarly, at infinite frequency, omega is infinite, XL will be open circuited, infinite reactance, ये open circuit behave करेगा. So at omega is equal to 0, capacitor behaves as open circuit, therefore current is 0. At omega is equal to infinite, inductor will behave as open circuit and again current will be 0. At some frequency where resonance occurs, omega naught, current will be maximum, that is I max, and it will be V upon R. अच्छा, अब इस वेरिएशन को तो आपने ड्रॉ कर लिया. Let's see what is property of circuit. At resonance, I is equal to V upon R. That means ये inductor and capacitor, they are producing no hindrance in circuit. I is just controlled by R. That means the combination of inductor and capacitor behaves as short circuit in case of resonance, and other resonance frequency it will behave as inductive or capacitive circuit. तो ये point पे आप लिख सकते हैं. Seventh property, at resonance, the combination of L and C behaves as short circuit. कोई भी हिंड्रेंस प्रोड्यूस नहीं करेंगे ये करंट. अगेन अगर इस वेरिएशन को आप ऑब्जर्व करें, you observe this variation of current at lower frequencies, conduction is less, current कम है ना. At lower frequency current is small or conduction is less. At higher frequency conduction is also less. At some frequency near about this omega naught or resonant frequency, conductance is high, the current is high. We can say कि lower frequencies को ये conduct नहीं करता है. It stops lower frequency and it passes a frequency band near about this omega naught. इसको mention करें, say we decided this level. Omega 1 lower cutoff frequency, omega 2 upper cutoff frequency. ठीक, तो एक frequency band of delta omega we have high conduction, and other than this frequency band we have low conduction. बोल सकते हैं?
जी सर.
Again, we can conclude that the circuit stops. Conduction नहीं कर रहा मतलब stop कर दिया. We can conclude that the circuit stops lower and higher frequencies. Circuit stops lower and higher frequencies and has high conduction. Or we can say it passes a frequency band near omega naught. Omega naught के आसपास conduction ज्यादा है, and other than these frequencies conduction कम है, मतलब वो कम कंडक्शन, मतलब वो स्टॉप कर दे रहा फ्रीक्वेंसीज को, इस डेल्टा ओमेगा को वो पास कर रहा है. ठीक. द प्रॉपर्टी इज लाइक it can be treated as band pass filter. ये बैंड पास फिल्टर की तरह ट्रीट कर सकते हैं कि इस फ्रीक्वेंसी बैंड को ये पास कर रहा है, एंड अदर देन दीस फ्रीक्वेंसीज इसको स्टॉप कर दे रहा है. ये एक बैंड पास फिल्टर. द कांसेप्ट ऑफ फिल्टर स्टार्ट्स फ्रॉम सीरीज आरएलसी सर्किट ओनली. फिल्टर किसको करना है? फ्रीक्वेंसीज को. फ्रीक्वेंसी बैंड को पास कर रहा है, जैसे बैंड पास फिल्टर. अदर देन दिस फ्रीक्वेंसी बैंड ये सबको स्टॉप कर दे रहा है, जैसा बैंड पास फिल्टर. नाउ कैसे डिसाइड करेंगे? वी हैव मैक्सिमम कंडक्शन एट ओमेगा नॉट, बोथ दैट इज क्लियर. नाउ हाउ वी विल डिसाइड ओमेगा 1 एंड ओमेगा 2? Based on the properties of electrical circuit elements, most of the elements can perform up to half of their power, rated power. Less than that, they are not able to perform. So those frequencies where power become half, suppose here power obtained is P, here it will be P by 2. Or for power to be half, current should be Im by root 2. The frequencies where power becomes half, or the frequencies where current becomes 1 by root 2 are called cutoff frequency. They are omega 1 and omega 2. यहाँ से ये एक फिल्टर की तरह यूज होगा, तो हम बोल सकते हैं इस फिल्टर की प्रॉपर्टीज क्या है. प्रॉपर्टीज ऑफ सीरीज RLC filter, or that is band pass filter. The properties there. We have पहली property, the for maximum conduction, frequency is what? Omega naught. For cutoff frequencies, omega 1 is called lower cutoff frequencies. Omega 2 is upper cutoff frequency, and is collectively called as cutoff frequencies or half power frequency, or so known as 3 dB frequency. So omega 1 and omega 2 are lower cutoff and upper cutoff frequencies. इन्हीं को आप half power frequency बोलते हैं, and it is also known as 3 dB frequencies. इनकी वैल्यू कैसे डिसाइड की जाती है? This omega 1 and omega 2 are the frequencies where power is reduced to half, or current is reduced to 1 by root 2 times. Clear? And this is also when this XL minus XC, आप इनका mod भी ले सकते हैं. XL minus XC must be equal to R. In that case, power will be reduced to half. This is the formula for calculation for omega 1 and omega 2. In first case, put XL minus XC equal to R for omega 2, and for omega 1, put XC minus XL equal to R. Clear? यहाँ तक कोई problem? Students, 13 students. यहाँ तक कोई problem है? Now, this bandwidth जो bandwidth pass हो रहा है filter से, it is delta omega, it is equal to omega 2 minus omega 1. These are the properties for filter. Now, what is a good filter? अच्छा filter कौन होता है? What will be ideal filter?
जो
केवल एक फ्रीक्वेंसी को पास करे. फिल्टर बहुत अच्छा फिल्टर होगा. तो फिल्टर की प्रॉपर्टी क्या होती है कि आपको सिलेक्टेड चीजों को पास करना होता है एंड यू रिमूव अदर देन दैट. तो अगर ये केवल एक फ्रीक्वेंसी को पास करे और बाकी सारे फ्रीक्वेंसी को स्टॉप कर दे, इट विल बी आइडियल फिल्टर. वो आइडियल हो जाएगा. फॉर बेटर प्रॉपर्टीज डेल्टा ओमेगा शुड बी स्मॉल. कम फ्रीक्वेंसीज पास होनी चाहिए फॉर दिस फिल्टर टू बी अ बेटर फिल्टर. तो इसको हम रिप्रेजेंट करते हैं क्वालिटी और सेलेक्टिविटी से. क्वालिटी फैक्टर और selectivity of this filter, it can be defined as Q is equal to omega naught upon delta omega. Omega naught is fixed. अब ये डेल्टा ओमेगा जितना कम होगा, क्वालिटी उतना ज्यादा होगा. For a good quality filter, bandwidth should be small. Clear? Also, quality factor in literature can be defined as Q is equal to reactive power upon active power. It is power loss in resistance. Now, at resonance condition, reactive power across inductor and reactive power across capacitor is same. Therefore, Q can be written as I square XL upon I square R, or Q can also be written as I square XC upon I square R. I square cancel. Q can be written as XL by R, or Q can be written as XC by R. And since XL and XC are equal, दोनों से रिजल्ट सेम आएगा. चेक कर लेते हैं. This quality factor, what is XL? XL is nothing but
omega L.
omega naught L 1R. And what is omega naught? 1 upon under root LC into L by R. If this is root L, this is L. ये cancel हो जाएगा. This Q will be 1 upon R under root L by C. Very important relation. ये डायरेक्ट ऑब्जेक्टिव क्वेश्चन है आपका. क्वालिटी फैक्टर ऑफ सीरीज आरएलसी सर्किट आप इस फॉर्मूले से भी निकाल सकते हैं. से Q is equal to XC. What is XC? 1 upon omega C. So it will be 1 upon omega naught CR. And what is omega naught? 1 upon under root LC. आप पुट करिए, will be root LC upon C by R. Again, C and C will be cancelled out. Root in square root. Q will be equal to again 1 by R under root L by C. अब किसी भी फॉर्मूले से निकालें. इंपॉर्टेंट है. selectivity or quality of band pass 1/r under root L by C। फॉर्मूला आपको याद होना चाहिए। आगे चलें। Now with same relation bandwidth can also be calculated. With same relation, bandwidth can also be calculated. That is, Q is equal to omega naught upon delta omega. Also, Q is equal to XL upon R. So we can write omega naught upon delta omega is equal to XL bar R. Yes. Omega naught upon delta omega is equal to omega naught L upon R. Omega naught cancel. This delta omega will be equal to R upon L. This is bandwidth of series RLC band pass filter. Clear? अब एक चीज और यहाँ पे बहुत इंटरेस्टिंग कि दिस डेल्टा ओमेगा और बैंडविड्थ ऑफ सर्किट, ये बैंड पास फिल्टर तो है, दिस बैंडविड्थ ऑफ सर्किट कितना फ्रीक्वेंसी बैंड को पास करेगा, इट डिपेंड्स ऑन आर एंड एल। bandwidth does not depend on capacitance. It is another objective question. The bandwidth of band pass filter does not depend on, किस पे डिपेंड नहीं करता है, कैपेसिटेंस। ऑब्जेक्टिव क्वेश्चन भी है आपका। Also for approximate analysis, if this complete bandwidth is delta omega, this can be approximately written as delta omega by 2, and this is also delta omega by 2. For approximate analysis, ये बुक्स में लिखा होता है, इसको कभी यूज मत करिएगा इस फॉर्मूले को। Don't use it for numerical calculation. This omega 1 is approximately equal to omega naught minus delta omega by 2, and omega 2 is approximately equal to omega naught plus delta omega by 2. This is only for exactly equal नहीं होता है, only for approximate analysis. कभी न्यूमेरिकल में यूज मत करिएगा इसको। एक्चुअल रिजल्ट आपको इधर से ही मिलेगा। यूज दिस रिलेशन फॉर कैलकुलेशन। क्लियर? तो ये एक बैंड पास फिल्टर है। इस बैंड पास फिल्टर की इतनी प्रॉपर्टीज हम डिफाइन कर सकते हैं। उसका सीरीज आरएलसी सर्किट एक बैंड पास फिल्टर की तरह काम करता है, एंड इट हैज रेजोनेंट फ्रीक्वेंसी, द पॉइंट फॉर मैक्सिमम कंडक्शन, देन उसका कट ऑफ फ्रीक्वेंसीज क्या होती है, देन उसका बैंडविड्थ क्या होता है, देन उसका सिलेक्टिविटी और क्वालिटी फैक्टर क्या होता है। वी कैन डिफाइन विद दीज रिलेशंस। ठीक, नाउ से हम लोग न्यूमेरिकल करते हैं। आपके पास कैलकुलेटर है सबके पास?
सर क्वालिटी फैक्टर सिर्फ सीरीज पे आता है क्या, पैरेलल में आता है?
बिल्कुल होता है, वो पैरेलल सर्किट हम लोग करेंगे भी अभी सीरीज वाले को कंफर्म कर लेते हैं पहले ना। देयर इज अ क्वेश्चन इन अ series RLC circuit, a series RLC band pass filter. R is equal to 2 ohm. Suppose XL is equal to 0.2 Henry. Suppose, and XC, yeah, L equivalent is inductance L, and XC not C के value ले लीजिए, and capacitance C is equal to 2 microfarad. Let me think. 2 microfarad, correct. Okay. Find A, omega naught, B, delta omega, C, quality factor, D, omega 1 and omega 2. आप लोग ट्राई करेंगे?
हाँ सर।
चलिए शुरू करिए. What is omega naught? कैलकुलेटर है ना आपके पास? Omega naught is what? 1 upon under root LC.
LC
1 upon under root 0.2 into 10 to the power minus 3 is millihenry na, into 2 into 10 to the power minus 6. This is equal to 0.2 और 2 to multiply हुआ 2 कॉमन बाहर निकाल देते इसको, 2 अंडर रूट में क्या बचा, -3 -4 -6 into the power -10, which is 10 to the power 5 by 2 is equal to 5 into 10 to the power 4. The resonant frequency is 50,000 radian per second. Omega naught is 50,000 radian per second. आप resonant frequency भी निकाल सकते हैं. F naught will be, what is omega naught? Omega naught is 2 pi F naught. It is 50,000. F naught will be equal to 50,000 upon 2 pi. Calculator value. What is 50,000 upon 2 pi?
7,957.7475.
7,900. 57.75
57.75
hertz. This will be in hertz. Next क्या पूछा आपसे?
bandwidth.
Yes. What is delta omega? ये फॉर्मूला आपको याद होना चाहिए, तो फिर परेशान हो जाते हैं फिर आप. Omega no, delta omega is R by L. What is R2? And L is 0.2 into 10 to the power minus 3. Delta omega will be 10 to the power 4. Right? Unit? The unit for delta omega will be 10 to the power radian
per second.
per second. Now, what is C? Quality factor. Quality factor is nothing but omega naught upon delta omega. Omega naught is 50,000 upon this is 10,000. Quality factor of the circuit is 5. Yeah. Now D. Omega 1 and omega 2. Put XL minus XC equal to R. This is omega L minus 1 upon omega C equal to R. आप इसका LCM लीजिए. This will be omega square LC minus 1 upon omega C equal to R. That means omega square LC minus 1 is equal to R omega C. Omega square LC minus R omega C minus 1 equal to 0. Now put the value of L and C. Omega square. L is what? 0.2 into 10 to the power minus 3. C is 2 into 10 to the power minus 6. Minus. R कितना है? 2. What is C? 2 into 10 to the power minus 6 into omega minus 1 equal to 0. Omega square. This is nothing but 10 to the power 4 or 10. 4 into 10 to the power 10 minus 4 into 10 to the power minus 6 omega minus 1 equal to 0. This is a simple quadratic equation. Use your calculator. While value of omega, दो values आएंगी. एक नेगेटिव आएगा, एक पॉजिटिव आएगा. What is the value of omega 1 and omega 2? Quadratic equation. Calculator में put करिए values को. Anyone?
5 into 10 raised to 4 minus 17.
17.
जी.
नहीं. ये minus 10 है, sorry.
Minus 10 है.
Yes. It will be somewhere about 59,000 and 49,000.
Fifth. 55,000.
5,249.37.
55,000.
249.37.
249.37. And omega 2?
माइनस में आ रहा है सर.
Answer?
माइनस 45,249.
Same. 45,249.37.
37.
Actually, this is omega 2. This is omega 1. Minus and ignore कर दीजिए.
हाँ सर.
You can ignore negative sign. For omega 1, we have to put XL minus XC minus XL equal to 0, na? For upper cutoff frequency, we put XL minus XC equal to 0. For lower cutoff frequency, we will put XC minus XL equal to R. वहाँ पे नेगेटिव साइन मल्टीप्लाई करना पड़ता है, तो आप जो आंसर में नेगेटिव साइन है उसको इग्नोर कर सकते हैं. These are cutoff frequencies. इस तरह से आप निकाल सकते हैं. क्लियर है? आगे चले.
सर वो माइनस क्यों वो करेगा सर?
माइनस इग्नोर कर सकते हैं आप, क्योंकि इक्वेशन चेंज हो जाता है. देखिए ऊपर से ऊपर. We divide this graph in two parts. At this point, omega naught, XL is equal to XC. In this part, XL is more than XC. And in this part, XC is more than XL. So for omega 1, we will put XC minus XL equal to R. And for omega 2, we will put XL minus XC equal to R. आपने केवल एक कंडीशन लिया ना? We have kept
हाँ जी,
XL minus XC equal to R. तो एक रिजल्ट तो मिल जाएगा. We will get omega 2. हाँ. अब दिस इज अ क्वाड्रेटिक इक्वेशन, तो आपने वो माइनस साइन तो एडजस्ट हो गया, लेकिन अगर आप ओमेगा 1 निकालना चाहते हैं देन अगेन यू हैव टू पुट XC minus XL इक्वल टू, आप दोबारा ट्राई करके कर सकते हैं.
जी समझ.
हाँ समझ गए. दिस इज यहाँ पे नेगेटिव साइन आ रहा है ना, बिकॉज
हाँ.
वहाँ पे ऊपर आप नेगेटिव से मल्टीप्लाई करते हैं. ये दोनों आंसर आपको सेम मिल जाएगा. एक नेगेटिव आएगा, एक पॉजिटिव आएगा, एंड यू कैन इग्नोर द नेगेटिव साइन. बोथ आर निकट ऑफ डिफरेंसेस. ओके, चलिए, अगर क्लियर हुआ है तो आप एक न्यूमेरिकल करिए. in a RLC filter is nothing but a circuit. RLC filter circuit which draw 5 ampere at resonance and has power loss of 250 watt. Its resonant frequency is 10 kilohertz and bandwidth is 1 kilohertz. Screen sharing possible. Resonant frequency is 10 kilohertz and bandwidth is 1 kilohertz. Find the circuit parameters. Circuit parameter बताइए. ट्राई कर रहे हैं.
सर रेजोनेंट फ्रीक्वेंसी मतलब ओमेगा होगा या एफ होगा?
F0 हर्ट्ज दिया है ना. यहाँ पे एक पॉइंट नोट करने वाला भी है. We have not mentioned the connection of circuit. It is only given we have a series RLC filter. It is not provided whether it is series circuit or parallel circuit. Right? Now, if it is not mentioned, you will always consider to be a series circuit. मेंशन नहीं किया है तो आप हमेशा सीरीज सर्किट मानेंगे उसको। एनी आंसर? Power loss occurs only in case of resistance. 10 ohm. Power loss is what? I square R. And this is 250 watt. Current is what? 5 ampere, 5 pi square into R. This R is equal to 250 upon 25. It is 10 ohm. R is equal to 10 ohm. Now we also know this is one parameter. R की वैल्यू मिल गई, L का और C का वैल्यू चाहिए. Also know that what is delta omega? R by L. Delta omega is nothing but 2 pi delta F. The R by L. Delta F is equal to R upon 2 pi L. In terms of hertz, what is delta F? Bandwidth? 1 kilohertz. 1 kilohertz is nothing but 1000 hertz. R is what? R is 10 ohm upon 2 pi L. So L will be equal to 10 upon 2 pi into 1000. What is the value of L? कैलकुलेटर प्रयोग करिए. (1.59 millihenry). 1.59 into 10 to the power, इसका वैल्यू 1.59 आएगा. 1.59 into 10 to the power minus 3 Henry, or L is equal to 1.59 millihenry. From third property, we can calculate C also. What is F naught? 1 upon under root LC. And given resonant frequency is 10 kilohertz, is 10,000 is equal to 1 upon under root 1.59 into 10 to the power minus 3 into C, squaring both sides. 10 to the power 4 square will be 10 to the power 8 is equal to 1 upon 1.59 into 10 to the power minus 3 into C. C will be equal to 1 upon 1.59 into 10 to the power minus 3 into 10 to the power 8. C का वैल्यू बताएं. If 1.59 again 1.59, ठीक है, आप क्रॉस चेक कर लीजिए, ये सिंपल कैलकुलेशन है. 1.59 1.59 1 upon 1.59 is 1.59 only.
0.628 आता है. 1 by 1.59.
1 divided by 1.59 बताइए
628.
0.68 कैसे आएगा? चलिए ठीक.
1 divided
0.628 and is 10 to the power minus 3 10 to the power 8 will be 10 to the power 5. ऊपर जाएगा plus. C will be equal to 6.28 microfarad. Using आपका आंसर बता रहा है.
सर थोड़ा ऊपर कीजिए तो सर.
सर वो 10⁸ कहाँ से आया सर आपका?
यहाँ से
सर इसमें अब 2 पाई नहीं लगाया था.
नहीं 2 पाई ये 10⁸
ओ हो
4
सॉरी
into
सॉरी
2
सॉरी
pi
सॉरी.
मेगा होगा सर, मेगा.
नहीं मेरा बोल. यहाँ पे 2 पाई भी आएगा.
अभी ठीक है.
Now this will be equal to correct. आपका आंसर सही था.
मेगा फेरत होगा ना सर ये?
माइक्रोफैराड होगा ना.
10 to the minus 6 तो माइक्रो है ना. 10 to the positive 5 आ रहा है.
डिनोमिनेटर में पॉजिटिव आ रहा है ना, ऊपर जाकर नेगेटिव हो जाएगा.
आप पॉजिटिव वाला लिख दिया था इसलिए.
Is 15.9 microfarad. I hope this is final answer correct. और ये भी स्क्वायर किया है ना आपने. थोड़ा सा इसमें भी 2 पाई का स्क्वायर
4 स्क्वायर
फाइनल आंसर
हो
कितना?
जाएगा.
हाँ, फाइनल आंसर यही आ रहा है 15.9 माइक्रोफैराड. So this is all about series circuit or resonance condition in series circuit, or it is all about band pass filter. आपको ऐसा ही for different circuits we have to take resonance condition. Next circuit is parallel RLC circuit. एग्जाम में ज्यादा नहीं आता है.
कौन सा वाला सर?
Parallel one.
पैरेलल वाला
Resonance-
ज्यादा नहीं आता.
मोस्टली सीरीज में ही कंटेंट खत्म हो जाता है, लेकिन हम लोग कर लेते हैं. रेजोनेंस कंडीशन इन पैरेलल RLC circuit. Resonance condition in parallel RLC circuit. We'll be having a parallel circuit R, XL, axis, capacitive reactance XC, given a common voltage supply V. In parallel circuit, voltage is constant, and by definition of resonance, for resonance condition, this QL must be equal to QC, that is V square by XL must be equal to V square by XC. The basic condition for resonance, V square cancel. Therefore, 1 upon XL is equal to 1 upon XC. Both sides up inverse कर दीजिए. This means XL must be equal to XC. Again, the condition for resonance is same in parallel and series circuit. It is XL equal to XC, or omega naught will be equal to 1 upon under root LC, or F naught will be equal to 1 upon 2 pi under root LC. These are the condition for resonance in parallel RL circuit. आप यहाँ देख सकते हैं, condition for resonance is same in series and parallel circuit, but the properties are not same. They are entirely different. वो properties अभी हम देखते हैं. आप नोट लिख सकते हैं. The condition for resonance in series and parallel RLC circuit are same, but properties are different. Properties अलग हो जाती हैं. हमने देखा था what is in case of series RLC circuit. In series circuit, impedance is added. So Z was equal to under root R square plus XL minus XC whole square. Whereas in parallel circuit, Z की जगह पे जैसे वहां पे admittance impedance add होता है, in parallel circuit admittance is added. Now Y will be equal to under root G square plus BC minus BL the whole square. This is for conductance and susceptance. In case of resonance in series circuit, Z was minimum and Z was equal to R. In case of parallel RLC circuit, ये 0 हो जाएगा and Y will be minimum and Y will be equal to G. Resonance condition. At resonance, BC minus BL is equal to 0. Therefore, at resonance, admittance is minimum. That means admittance minimum. What is admittance? Inverse of impedance. That is, impedance will be maximum. Maximum impedance means minimum current. Therefore, at resonance, we have minimum current. It's there in circuit. वहां पे सीरीज सर्किट में रेजोनेंस कंडीशन में करंट मैक्सिमम होता है. In parallel circuit, at resonance, current is minimum. Again, if we plot I versus omega, plot graph between I and omega, we will get omega. This is I. How will be there? The variation in current or graph. What is XL? It is what? This is omega L. What is XC? 1 upon omega C. Put omega equal to 0. XL is 0. That means it will behave as short circuit. Short circuit मतलब current कितना जाएगा? Infinite. At omega is equal to infinite, XC will behave as short circuit. 1 upon omega C. Omega infinite, XC 0. It will behave as short circuit और current यहाँ से जाएगी infinite. At omega is equal to 0, current is infinite. At omega is equal to infinite, current is infinite. At some point, current is minimum. कौन सा point? At omega naught. current is minimum, and that is equal to V upon R. फिर एक्सेल एक्सी चेंज होंगे और करंट की वैल्यू इंक्रीज करेगी, देख सकते हैं. ऑल्सो देखिए, एट ओमेगा नॉट एक्सेल एंड एक्सी आर सेम, both inductor and capacitor will be having equal current. Say omega L is decreased. अगर ओमेगा घटाते हैं ना तो एक्सेल की वैल्यू डिक्रीज करेगी और एक्सी की वैल्यू बढ़ जाएगी. ज्यादा करंट कहां से जाएगा? More current will be there in inductor. Now if frequency decreases, the circuit behaves as inductive circuit. It is opposite nature. In series circuit, a series resonant circuit, if frequency decreases, it was behaving as capacitive circuit. In parallel RLC circuit, if parallel RLC resonant circuit, if frequency decreases, it behaves as inductive circuit. Next point. कितने point हो गए थे? Now fourth point. At omega less than omega naught, सर्किट कैसा बिहेव करेगा? सर्किट behaves to be inductive. To be inductive. At omega more than omega naught, higher frequencies, circuit behaves to be capacitive. ये हो गई प्रॉपर्टीज. अब इसके फिल्टर की प्रॉपर्टी भी देख लेते हैं. ये भी एक फिल्टर की तरह काम कर रहा है. At this frequency, there is minimum conduction. So we can say at frequency around omega naught, conduction is minimum. At higher frequencies, conduction will be more. ज़्यादा conduction होगा. ऐसा देखने को कह सकते हैं कि at this frequency band, conduction is not present. At higher frequencies, there is more conduction. At lower frequency, there is more conduction. So the filter is passing lower frequencies. Also, it is passing the higher frequencies, and this frequency band is stopped by the filter. This frequency band पे conduction नहीं है. Minimum conduction. We can say it is a band stop filter or band reject filter. क्योंकि ये lower frequency को पास कर रहा है, higher frequency को पास कर रहा है, केवल इस frequency को ये पास नहीं कर रहा. This parallel RC circuit also behaves as a filter, but the properties are different.
सर अभी कल और एक बार एक्सप्लेन कीजिए तो सर.
We observe the conduction in this circuit. This is I versus omega graph. At lower frequencies, there is more current. At higher frequencies, it has more current. At this frequency band, current is small current. Conduction is less in this frequency band, and conduction is high in other frequencies, lower and higher frequencies. Right. So this filter is passing lower frequencies by providing conduction. Filter is passing lower frequency, it is passing higher frequency, but in this frequency band, conduction is not there. That means it is stopping this frequency band. So this is a band stop filter, and series circuit was band pass filter. Right. Now, note पे लिख लीजिए. This parallel RLC circuit passes lower and higher frequencies, whereas it stops a frequency band around omega naught, that is delta omega. Delta omega is the frequency band stopped by this filter. That is, it acts as band stop filter. Again, definitions are same for bandwidth. It is described by double power frequency omega 1 and omega 2. XL minus XC equal to R put करके आप निकाल सकते हैं. For omega 1 and omega 2, put XL minus XC का mod equal to R. वहाँ से मिल जाएगा आपको. Now,
सर
जी.
सर लास्ट टाइम आप जो एक बार बताया था ना सर, वो करंट मल्टीप्लायर के बारे में सर,
हाँ,
केरल का केस में
मैग्नीफायर सर्किट.
सर, उसको ये
जी.
सर ये सर्किट में ये वेवफॉर्म से सर बता सकेगा क्या सर
नहीं.
एग्जैक्टली किस तरह से?
नहीं.
Okay.
जो आप वैल्यूज लेंगे, in some cases we can get the inductor and current, capacitive current more than the total current. Therefore, it was called it is current magnifier circuit. Parallel RLC circuit is a current magnifier circuit. लेकिन अभी हम लोग total current को केवल देख रहे हैं. तो केवल total current देख रहे हैं. IC और IL नहीं निकाल रहे.
इंडिविजुअल पे नहीं जा रहे हैं ना सर? ओके.
Okay. Now,
जी.
also, quality factor or selectivity will be omega naught upon delta omega, and Q is equal to, again it is by definition, reactive power upon active power. What is reactive power? It is a parallel circuit, therefore voltage supply is fixed. In terms of voltage, reactive power is V square by XL. Active power is V square by R. And since XL and XC are same, equal, therefore we can also write V square by XC upon V square by R. Therefore, Q will be equal to V square cancel. It will be R upon XL. और Q will be equal to R upon XC. आप दोनों में से कोई भी फॉर्मूला यूज कर सकते हैं. With both formula, you will get same result. Now, Q will be equal to R upon XL. XL is what? Omega naught L. Put the value of omega naught. It's 1 upon under root LC. It will be under root LC in numerator R upon L. L and L again cancelled out. This Q will be equal to R under root C by L. Again, important relation. Okay, direct objective question. Quality factor of series RLC circuit is, sorry, parallel RLC circuit is R under root C by L. यहाँ से भी आपको सेम रिजल्ट मिलेगा. Here again for bandwidth, yes, Q is equal to omega naught upon delta omega, and Q is equal to XL upon, sorry, Q is equal to R upon XL. ये दोनों इक्वल हो जाएंगे. Therefore, omega naught upon delta omega is nothing but R upon omega naught L. Cross multiplication. Omega naught square L is equal to R into delta omega. What is omega naught square? 1 upon LC into L is equal to R into delta omega. Ln and cancel. Delta omega will be equal to 1 upon RC. We can see that in this formula, inductance is not present. Inductance is not present in this formula. Therefore, bandwidth of band stop filter, which is nothing but parallel RLC circuit, does not depend on inductance. The bandwidth of series circuit does not depend on capacitor, and bandwidth of parallel circuit does not depend on inductor. Inductor पर depend नहीं करता. Next, again, ये तो theory है. अब इस पे numerical बनाते हैं.
सर
Yes.
इसका मतलब सर सीरीज में मान लो कि सर रेजिस्टेंस और एक इंडक्टेंस देखे रखा है ना सर, मतलब वो दोनों सीरीज में है, इसके बाद एक इंडक्टेंस जो है पैरेलल में है इसके साथ, सीरीज और इंडक्टेंस के साथ. तो सर अगर उसमें हमको बैंडविड्थ निकालना होने से सर रेजिस्टेंस का सिर्फ वैल्यू लेगा?
नहीं. हेडिंग क्या है आपका? It is the properties of parallel RLC circuit. The circuit defined here is fixed. We are talking about only parallel RLC circuit.
मतलब सर सीबी होना
Not
पड़ेगा
any
ना?
other case. In any other case, the condition will change.
Sir, what if the resistance and the inductance are including in series branch?
Next करेंगे उसको भी. देखिए, we have to define or describe two circuits in detail. One is parallel RLC circuit and one is series RLC circuit. For any other case, analysis will be different. हम लोग later on उसको करेंगे. अभी नहीं. अभी जो बात कर रहे हैं वो केवल series और parallel के लिए. And in that case also, if not mentioned, circuit is always considered to be in series. Like, एक क्वेश्चन देता हूँ आपको. If values of R, L, and C are doubled, what will be the effect on omega naught, delta omega, and C? Selectivity or quality factor of circuit. इन पे क्या effect पड़ेगा? In this question, it is described, whether it is described that it is series or parallel circuit. बताया है क्या? Series parallel circuit कौन सा है ये? नहीं बताया. If not mentioned, we will consider to be in
Series.
series. R, L, and C are in series. Now, what will be the effect on delta omega, omega naught, and Q?
Omega naught will be half.
1 upon under root LC. L is half, L is double, C is double. It will be half. What will be the effect on delta omega?
Till quarter times 1/4.
1/4. Just now.
Delta omega is R by L.
Series. Okay.
Oh, there's no chance. Yes.
Series.
What is Q?
जी.
Quality factor will also be
Just now.
half.
now again. If this question is modified and it is mentioned for a parallel RLC circuit, if R, L, and C are double, what will be the effect on? Again, option same. What will be the effect on delta omega? Yeah, sorry, पहले omega naught. Omega naught, delta omega, and equal to क्या effect आएगा इन पे?
Omega not
Omega-
double.
Omega naught will be
Half.
twice.
Delta omega is 4 times.
Omega naught is again 1 by under root LC na for parallel circuit also.
half.
It will be half.
Delta
Delta
omega
omega?
double. 1 by 4.
1 by 4 times
Quality
Q?
factor double.
double. I hope आप रेजोनेंस और कंडीशन और थोड़ा बहुत फिल्टर आप समझ चुके हैं.
जी
Okay.
सर.
This was case for series circuit, especially, and parallel circuit. Now, if it is not necessary that the elements are connected in series or parallel only, for any other circuit, रेजोनेंस कैसे निकालें? Note if you just. एक जनरल मेथड है to find resonance in any other circuit. To find resonance condition in any other circuit, क्या करना होता है? पहला पार्ट, find total impedance or admittance of circuit. Either you can calculate total impedance or you can calculate total admittance, anyone जो easily हो जाए. Then represent it in rectangular form. उसको rectangular form में लिखना होगा. And then put imaginary part equal to 0. This is the method to find the condition for resonance in any other circuit. ऐसा करने से you can get the condition for resonance. Example लिखते हैं, करेंगे कैसे?
सर लिख के
Fine.
खत्म नहीं हुआ है सर.
जी,
लिख के खत्म नहीं हुआ, उसको तो ऊपर कर दी.
okay. ये कंप्लीटेड, लिख लिया?
हाँ सर।
Okay. Suppose there is a circuit like we have a voltage source, alternating voltage source, variable frequency, and connection is like this is R and this is L and this is C. At what frequency resonance will occur? Check. Now we know that impedance is added in series circuit. In parallel circuit, admittance is added. इसका impedance Z1 will be R plus J omega L, and this Z2 will be 1 upon J omega C. अब ये दोनों parallel में हैं. In parallel, admittance is added. Therefore, total admittance of circuit Y will be equal to 1 upon R plus J omega L plus 1 upon J omega C. The Z2 is 1 upon J omega C. Therefore, इसका inverse लेंगे ना, 1 upon Z2 लेंगे. It will be J omega C. But till there is a complex number in denominator, we cannot separate real and imaginary parts. So we have to rationalize this term. Therefore, Y is equal to 1 upon R plus J omega L into R minus J omega L upon R minus J omega L plus J omega C. Multiply करिए R minus J omega L ऊपर A plus B, A minus B, A square plus B square, but J का square is also minus 1. This will be R square plus omega square L square plus J omega C. Now we can separate real and imaginary part. आप लोग कैलकुलेशन चेक करिए प्लीज, गलती ना हो कि बहुत सारे टर्म्स आते हैं तो यहाँ पे लिखने में कैन बी राइट ऑन दिस टच पैड, लिखता नहीं है. Y is equal to R upon R square plus omega square L square minus this, take this J common, plus J is common. This is omega C minus omega L upon R square plus omega square L square. Real and imaginary parts separated? Now, for resonance, क्या करना है? Put imaginary part of Y equal to 0. That means omega C minus omega L upon R square plus omega square L square is equal to 0. Omega omega cancel, common लेकर के. Means L upon R square plus omega square L square is equal to C. Again, cross multiplication. L equal to C R square minus omega square L square C. Right. Omega square L square C is equal to C R square minus L.
सर प्लस होगा, प्लस
कुछ गलत हो रहा है क्या?
सी आर स्क्वायर प्लस ओमेगा स्क्वायर एल स्क्वायर सी.
This is plus ना. This will be L minus C R square. Put again cross multiplication, omega square is equal to L minus C R square upon L square C. करेक्ट है?
जी सर.
सेपरेट भी कर सकते हैं इसको. ओमेगा स्क्वायर इज इक्वल टू 1 अपॉन एल सी माइनस सी एन सी कैंसिल आर स्क्वायर बाई एल स्क्वायर, राइट? हाँ सही. ओमेगा इज इक्वल टू अंडर रूट 1 बाई एल सी माइनस आर स्क्वायर बाई एल स्क्वायर. This is the condition for resonance in given circuit. इस फ्रीक्वेंसी पर रेजोनेंस होगा. This is condition for resonance in above circuit.
सर तब तो रेजोनेंस का कोई स्पेसिफिक फॉर्मूला नहीं है ना, वो सर्किट
नहीं,
का
नहीं,
पैरामीटर्स पे
नहीं,
डिपेंड
नहीं,
करेगा ना सर.
XL equal to XC is only for series circuit and parallel circuit. It is not the definition of resonance.
ओके.
अब इस एग्जांपल से बहुत कुछ क्लियर होता है.
जी.
Like we think that there is no role of resistance in case of resonance circuit, but in this formula R is there. रेजिस्टेंस भी रेजोनेंस कंडीशन को अफेक्ट कर सकता है. ठीक.
Yes, sir.
Also, if R is equal to 2 ohm, L is equal to 1 Henry, and C is equal to 1 farad, so omega naught will be what? The resonance frequency ना omega naught कर लीजिए. ओमेगा नॉट का वैल्यू बताइए.
√1 -3.
अंडर रूट -3. Is it a real number?
Imaginary.
Imaginary. But frequency is a real physical quantity. It cannot be imaginary. That means a frequency you can vary it from 0 to infinite. Omega naught is equal to under root -3 is not possible. It means this circuit will never come in resonance. तो यहाँ से दो पॉइंट्स क्लियर होते हैं. फर्स्ट पॉइंट इज कि व्हाट वी थिंक अबाउट रेजोनेंस इज इट डज नॉट डिपेंड ऑन रेजिस्टर. इट इज नॉट ट्रू. रेजिस्टेंस कैन अफेक्ट द रेजोनेंस कंडीशन. अदर प्रॉपर्टी जो यहाँ पे क्लियर होता है कि इट इज नॉट नेसेसरी दैट इफ इंडक्टर एंड कैपेसिटर is present in circuit, the circuit has to be in resonance. It is possible that R, L and C are present in a circuit, but the circuit never comes into resonance. It is possible. A possible है. Clear? Now, question. The question in note लिख लीजिए इसको. From above example, following can be concluded. क्या conclude कर सकते हैं आप? First point, the resistance may affect the condition for resonance. Resonance condition को affect कर सकता है. Second, it is not necessary that circuit containing L and C has to be in resonance at some condition. LOC कभी रेजोनेंस में नहीं है, ऐसे पॉसिबल है सर्किट में होने के बाद भी वापस में रेजोनेंस में कभी ना। क्लियर? होमवर्क करेंगे आप लोग?
जी सर।
ये आपका होमवर्क है। फाइंड द कंडीशन फॉर resonance in given circuit. पहला सर्किट है L, R, this is C. B. R, L, so this is R, this is C. ये दोनों सर्किट में रेजोनेंस कंडीशन निकालना है। This is all about resonance in AC circuit. So from this point, your single phase AC circuit is over. In next class, we will cover the polyphase AC circuits. Next class में polyphase AC circuit करेंगे। 5 days का more class is there for network analysis.
सर
जी,
ये मैग्नेटिकली कपल सर्किट ये सब तो कराया ना
मशीन में,
मशीन में है।
मैग्नेटिक सर्किट में, it is not electric circuit.
इलेक्ट्रिक सर्किट में है तो
एक introduction of magnetic field is required for that.
ठीक है, थैंक यू।
Thank you. Happy Sunday.
सर
जी,
मैग्नेटिक सर्किट है क्या उस पे सिलेबस में?
बिना मैग्नेटिक सर्किट के एक मशीन नहीं पढ़ पाएंगे आप।
तो हम लोग क्या करेंगे, इलेक्ट्रॉनिक्स वाला पढ़ ले क्या?
हाँ, पढ़ना पड़ेगा आपको भी, कपलिंग तो है ही।
कपलिंग ना, हाँ। ठीक है सर।